Okay, so here's practice exam number 1, the last few questions, starting at number 34. It says, this graph shows a box plot for CPA and actuary salaries. So here's the CPA box plot. Remember, this is the minimum. It's the CPA that makes the least makes $30,000, or maybe that's a little bit higher than 30. It's like right there, I don't know. And this is the first quartile. This is the median. This is the third quartile. And this is the maximum salary for CPAs. Remember, it's a box plot, so that means 25% of all CPAs are in that zone. 25% of all CPAs are in that zone. 25% of all CPAs make those salaries, and 25% of all CPAs make salaries in that range. And now coming down for the actuaries, that's their minimum salary. That's their Q1. Here's the median salary, the Q3, and the max salary for actuaries. That means 25% of all actuaries make salaries in that range, 25% in this range, 25% in this range, 25% in that range. Okay, so what's their question? If a person's salary is at the third quartile for actuaries, where's that? Actuaries, third quarter, right there, which is the same as that max, notice. So if the person's right there, if they're at the third quartile mark for actuaries, they're also at the maximum for CPAs. It's the same mark, right? Let me actually get rid of those. See those? See how those are at the same exact spot? Whoops. See how those are the same spot right there? That's the third quarter mark. That's Q3. Oh, sorry, I'm messing this all up now. Bring it down here. This is the Q3 mark, which is right at the max for CPAs. Actuaries down here, CPAs up there. He makes less than what percent of CPAs? So if he's right here, which means he's right here, he makes less than how many CPAs? Well, if he's right here, he makes more than all the CPAs. There's 25, 25, 25. There's 100% of the CPAs. There's 100% are less than him. 0% are higher than him. Right? 0% are higher than him. So he makes less than 0% of the CPAs. So here's number 35. This graph shows the box plot for a quiz given to 80 students. Okay, which of the following could possibly be the 52nd percentile? That means 52% of the way through the data. Well, remember, this is the end of the first quarter. This is halfway. Right here's halfway. This is, right, there's 25% of the data's here, 25%'s here, 25%'s here, and 25%'s here. So where is 52% of the way? Well, it's about right there. 52% of the way through the data is just past the halfway point, isn't it? It's just past the middle. The median is the middle. 61's the middle. So the halfway point, this is the middle. So the halfway point is just past that. 52%. I'm sorry, 52% is just past halfway. So which number is just past halfway? 63. It's got to be that. Couldn't be any of those other numbers, right? 59 is before 61, it's before halfway. 45 is before halfway. 52 is before halfway. 70 is way over here past the 3/4. So there we go. It's got to be 63. It's the only one possible. Okay, number 36. For these three histograms, put them in order according to their standard deviations from smallest to largest. Okay, remember, this is really testing if you remember what standard deviation means. It's a measure of the spread. It's the average distance from the middle. So standard deviation is spread. It's average distance from the middle. Okay, average distance from the middle. Okay, so to figure this out, which of these, so it's all about the spread, the average distance from the middle. So bigger, so let me see, bigger spread, or I should say more spread. More spread means a higher standard deviation. Less spread, meaning more centered, means lower standard deviation. So more spread out is higher standard deviation, less spread out, more centered, is lower standard deviation. So which one is, of these A, B, and C, of these three histograms, which one is most centered, has most data in the middle? A. Most centered, lowest standard deviation. Which one is second most centered? This one, he's in the middle. And then this one here is the most spread out, right? Because the data is really low and really high. It's spread, it's not centered, it's most spread out, which means it has the highest standard deviation. Standard deviation is a measure of spread. So the lowest would be A, followed by C, followed by B. Should be A, C, B. Because from smallest to largest, A, C, B. There it is. Okay, so for this question, the average weight of a newborn German Shepherd is 485 grams with standard deviation 57. And then we change gears. The average weight of a Labrador Retriever is 282 with standard deviation 21. And the average weight of a Poodle is 176 with standard deviation 8. And then we go back to the German Shepherd talk. Rover the German Shepherd is 400 grams. Max Labrador Retriever is 240. And Fluffy the Poodle is 184. Which of these three puppies is the smallest relative to its breed? That is, compared to other German Shepherds, just how small is Rover? And compared to other Labrador Retrievers, how small is Max? And for Poodles, how small is Fluffy? Rank the puppies relative to each of their breeds, from smallest to largest. Whenever they say relative, you should think z-score. You have to do z-score. See, that's how you can compare different data sets with each other. Because a z-score will tell you how large or small a number is within its data set. So, right, because, German Shepherds are, have a certain kind of average, 485 in standard deviation. Labrador Retrievers are not as big as German Shepherds, and then Poodles are even smaller. So we're wondering, for their different groups, which of these Poodles is actually smallest? I'm sorry, which of these puppies, what are these newborn puppies, is actually smallest compared to their breed? So whenever you're comparing different types of groups and you want rankings from group to group, that's relative, that's z-score. That's what z-score does. It tells you how big or small the item is within its group. So let's start then with Rover. I'm writing Rover. Rover. Rover's z-score. Remember the formula for z-score? It's his score, his weight, minus the mean over the standard deviation. So Rover, who's a German Shepherd, Rover, what does Rover weigh? Rover was born at 400. That's Rover was born 400. Minus the mean for Rover, 485, over Rover's standard deviation, 57. So I'm going to get a number there. I'm getting negative 1.4. Now remember, when you put this on your calculator, you want to go 400 minus 485. Hit enter first, then divide by 57, and hit enter. You got to hit enter that first time before you divide. After you subtract, you got to hit enter, then divide and hit enter. So now let's go on to the next one. I'm going to do max and get a z-score for max. Max is, it'll be score minus mean over standard. So for Max, who is the Labrador Retriever, Max, where's Max? Max was born at 240. So Max's birth weight minus the mean for Labrador Retrievers is 282 over the standard deviation, which is 21 for Labrador Retrievers. So I'm getting, let me see, minus 2. Okay. And finally, we've got Fluffy. And the z-score for Fluffy the Poodle, same form as score minus mean over standard deviation. So Fluffy came in at 184 grams minus the mean for Fluffy, 176, over the standard deviation for Fluffy, 8 for poodles, I mean, is that. And I think that comes in at 1, positive 1. Okay, now what do those numbers mean? This means Rover is minus 1.49 standard deviations below the middle. That's what that number means. That's what a z-score is, if I can separate these. So minus 1.4, minus is below. So Rover is weight is below average for German Shepherds. How much? It's down about 1.5, 1.49 is close to 1.5, negative, so it's below. Negative is below, positive is above. That many standard jump amounts, standard deviations, right? The standard amount that people are off of the middle, standard deviations below the middle. So whereas Max, let's come in with Max now. Max is 2 standard deviations below the middle. So Max is quite a bit lighter than the average, whatever he is, Labrador Retriever. He's 2 full standard amounts below the average. He's really small for Labrador Retrievers. And then Fluffy is plus 1. So Fluffy is above average, actually, plus 1. Standard deviation above, because Fluffy's positive. So even though Fluffy only weighs 184 pounds or 144 ounces or grams, I guess is grams, which is less than the other two, he weighs more than the typical poodle. 1 standard deviation above the typical poodle. So Fluffy's big compared to other poodles. So he's 1 standard deviation above. His z-score is plus 1. 1 standard deviation above the middle. All right, what do they want? They want us to rank from smallest to largest. So which z-score came in smallest? Smallest was the negative 2. Max. The middle one was minus 1.49, which is Rover. Rover came in the middle. And the largest z-score was here with Fluffy. So Max, Rover, Fluffy. Max, Rover, Fluffy. There it is, from smallest to largest z-score, which means compared to their group. There we go.